Hello there. Let's talk about number bases. So what are number bases? You've probably at some point heard someone say, hey, I can convert between decimal and binary, or between decimal and hexadecimal, or hexadecimal and binary. And you thought that that person was way cooler than you were. Well, they are way cooler than you. But if you watch my videos, maybe you can be just as cool as them. Anyway, so what do we mean by number bases exactly? We'll start with decimal, which is the number system that everybody already understands, I hope. So in decimal, you have 10 characters, right? So we'll say like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like 10 possible characters. So decimal is actually base 10. I'm going to write base 10 here. Decimal is base 10 because it has 10 available characters. The next thing is binary. You've probably heard of that before. Even a lot of non-computer scientists understand binary at least a little bit because it's just ones and zeros, right? This is how your computer represents information. All characters, all numbers, all floats, all everything, they really just come down to zeros and ones inside of the computer. And it's not like there's an actual 0 or an actual 1 anywhere. It's more like there's a certain voltage that represents a 1, or there's a different voltage that represents a 0. You can think of it as just like voltage or no voltage, but that's not always the case. But, you know, long story short, it's just ones and zeros. So in binary, we can just represent a 0 or we can represent a 1, and that's it. Because there's only 2 characters that we can use to represent numbers, we call this base 2. So that's binary. Now, not a lot of people have heard of hexadecimal outside of computer science, but hexadecimal is another number system that we can use, which uses base 16. The reason we use hexadecimal is because it kind of compacts a number. I'll show you in a second how it can represent the same number, but with less characters. You can imagine in binary, if we have base 2, there's only 2 characters. That means the same number in decimal versus binary, it's probably going to be a lot longer in binary. You can imagine that, right? Because, you know, it's not like the actual numbers change that we're trying to represent. It's just that the representation changes. So hex or hexadecimal, we have 16 different characters. Did I say 15 a moment ago? Sorry if I did. So we start with the normal ones that base 10 has, decimal has. So we go 3, 4, 5, 6, 7, 8, 9. So that's 10. Then to represent the extra 5, we do A, B, C, D, E, F. Sorry, extra 6. I knew I was going to say 5 at some point. So in hexadecimal, we have the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. For a total of 16 characters, or one digit can represent a value between 0 and 15. So let me just write base 16 here. So this is the basics of the differences between the number systems. Let me show you a quick example. Let me see if I got my calculator here. Hopefully it'll work. Okay. I'm going to do, let's see, variables. So how do you get into this one? Mode, oh, number base. So I'm going to do, let's just pick a random number in decimal. So I'm going to say, like, you know, just hit the characters a few times and hit enter. So you can see that if I type a number in decimal and show it in decimal, then, well, it's the exact same size as you probably have suspected. But if I represent this exact same number in binary, you should probably expect that the representation is going to be way longer because, again, binary only has 2 characters to work with, so it's harder for it to represent the same information. So I'm going to change the expression base here to binary. Oh no, what's happening? What's going on here? Expression base. Oh, I did the wrong thing. Decimal is the expression base. Binary is the result base. Okay. So that same number that we had before, 871, 876, 42, look at how huge it is in binary. It takes up a lot of your screen, right? So we use binary because it's the closest representation to what the actual machine has, so that's good. Especially if you want to start manipulating individual bits for one reason or another. It's good to know how to, it's good to understand binary. But hexadecimal is useful, like I said before, to compact the same number. So again, because the base of the original number is 10, you know, we had the original number in decimal. If we show a hexadecimal version of it, it should be shorter because there's 16 characters to work with. It's easier for it to represent the same information. So the result base, I'm just going to click hexadecimal here and look at how short that number is. The original number is 1, 2, 3, 4, 5, 6, 7, 8. It's 8 characters long, but the hexadecimal number is 2, 4, 6, 7 characters long. And that savings in characters will go up and up and up the more, the longer the original, or the bigger the original number is. Let me see if I can just add some more numbers here. Okay, let's see if we get more savings here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so the original number is 15 long. And here we have 2, 4, 6, 8, 10, 12, 13. So that's a savings. Now think about it this way. This is a huge savings compared to binary. Let's go back to binary real fast. Same number, which is currently in hex. As soon as I start showing it in binary, the number explodes. So there are a lot of numbers, especially if you have a 64-bit number, which you work with a lot in assembly or even just C++. If you were to just take, one of those 64-bit numbers and try to express it in binary, it's just kind of like, it's really, really long. And if you want to represent anything even a little bit bigger, like 128-bit numbers, or even the contents of memory from, one memory location to another, binary is just going to explode and fly off the screen. So this is why, this is one of the biggest reasons why we use hexadecimal, because it's easier to see what's inside of the computer. It's easier than decimal and it's easier than binary, at least once you understand hexadecimal. One other thing that I want to show you real fast. Let me see, let me change that back to decimal so I don't screw myself later. Okay. Suppose that you wanted to represent a number in binary. Sorry, let's say decimal. Well, we'll say like 1, 2, 3, 4, right? And then you want to represent a number in, well, actually, let's not do 1, 2, 3, 4. Let's say like 1001. And then you want to represent a number in binary, and you write 1001. And then you want to represent a number in hexadecimal. You could also have 1001, right? The problem is that each of these numbers are actually different numbers. They only look the same because the character representation is the same, but not the actual number. So how do you sort of like differentiate and make sure that the person reading the numbers that you've written down knows what base they're in? Because if you're a computer scientist or you're doing some kind of crazy math, then, well, it might not be obvious, and you want to be careful that the person doesn't misinterpret your results. Okay, so let me do that thing again real fast, just to prove to you. What am I doing here? Units, no, mode. Okay, so I'm going to say, if I write 1001, I'm going to display it as decimal, but the input is first going to be decimal. So in decimal, 1001 is 1001. Okay, that's fine. But if this 1001 was actually a binary number, I'm going to say that the expression base is binary here. Notice how the real number is actually 9 if you represented it in decimal. And if instead the expression, like the original number, was, the characters were hexadecimal, then the real decimal version of 1001 would be 4097. That's 3 totally different numbers. So you got to be careful that you know what you're reading, and you got to be careful that you help the person reading what you're writing down if you're trying to transmit this information. So with hexadecimal, a really, really common prefix that everyone should use is OX. OX, and then any number after that, it usually just tells the person reading, this is a hexadecimal number, so there's no ambiguity. Same thing for binary, you'll just say like OB, and then for decimal, you just leave it alone. I think there's another prefix you can use, but I usually don't use anything. But at least OB says this is binary, and OX means this is hexadecimal, and then nothing just means, okay, just default to human reading, just decimal. Okay, this was the basics of number bases. In other videos, I'm going to talk about how to actually convert between these 3 bases. Maybe in the future, at some other point, in some other video far off in YouTube land, I might talk about octal or some other base, but in the immediate future, it's going to be decimal, binary, and hexadecimal. So I hope you've enjoyed this video. I'll see you in the next one. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.